Now I'll introduce you to another concept, derivatives. This is advanced, but not very complicated. And if you want to, you can feel free to skip to the next topic, which is statistics and things like that. But bear with me, and hopefully this will be very easy. It's a very simple concept, very simple. Okay, here it goes. Life is all about change. Okay, nothing is static. We want to understand how change happens. Okay, let's go back to the same old example. Your age, your dad's age, and just to extend the line, this is 30 when you're 0. So it's a okay. The definition of derivative is very simple. Okay. So far we talked about relationship between your age and your dad's age. A derivative is the relationship between the change in your age and the change in your dad's age. Okay. Because in life and nature, change is so common, and you have to understand when one thing changes by a certain amount, how much does the other thing change? Okay, that's what a derivative is. The strict definition is change in your dad's age divided by change in your age is the derivative. Okay, if you plot this changes with respect to your age, that's what you'll get. Now, anyone who has taken calculus can do it like in a minute. Okay, dad's age equal to your age plus 30. D of dad's age divided by D of your age is equal to 1. Okay, everyone knows that in calculus. But I wanted to make it very explicit, very picturesque. Okay, not picturesque, pictorial. Now, let's say when you age from 25 to 35, okay, how much does your dad age? 55 to 65, right? Take this change, 10 years, divided by, take your change, 10 years, is equal to 1. I mean, people who did this figured that out in other ways, but we know that through very simple explanation that the change in your dad's age divided by change in your age. So when you age by n years, your dad ages by 10 years. When you divide them, you get 1. That's what it means. Uh, Now let's look at a more advanced function like quadratic function and see how the change happens. Okay, so students from calculus know that it's very easy to compute the derivative of a quadratic function. But going back to our alien example, so there is this alien whose age is equal to your age square. Going back to our example, right? This dude ages really fast after some point. Like you keep aging at 1 year, 1 year, 1 year. He goes like 1 year, 4 years, 9 years, 16 years, 25 years, moves really fast. Now, if I were to take the derivative, which is the change in alien's age at any time divided by change in your age is twice your age. What does it mean? What does it mean? Okay, let's take an example. When you're 0, the alien is 0. When you're 1, alien is 1. When you're 3, the alien is 9. When you're 5, the alien is 25. Now, you're aging by 1 year at a time, right? But let's see how the alien is aging. So when you grow to 1 year, like when you age by 1 year, the alien ages by 1 year. When you're 2 years old, which is, you age by 1 more year, the alien ages by 3 more years. And then the alien ages by 5 more years. How do I do that? 9 minus 4 is 5. 16 minus 5 is 7. So you'll see that the alien will age by 1, 3, 5, 7, 9, 11, 13, blah, blah, blah. So that's how the alien is aging. And if I take the change in alien's age divided by your age, it'll be the same thing because we're incrementing our age by 1 at a time. It'll be 1, 3, 5, 7, 9. You'll see that at any point, let's say you're 100 years old, and if you grow by 1 year, 1 more year, the alien will approximately age by 200 years. Okay, that's what the derivative is. So if you just follow this pattern, I'll graph it out. Okay, instead of graphing your age versus your alien's age, what we're going to do is delta your age and delta alien's age. Okay, and the coolest part about all this is that this is just another function. Okay, the change in your age is related to the change in alien's age. And here is where you will stop. I'll try not to go beyond it because this is more than enough for you to understand derivatives and understand functions. Now, if you were to plot the changes, it will be a straight line. And how do we know? We know that the relationship is twice your age. So when you go from 0 to 1, the alien goes 1, and when you grow from 1 to 2, when you grow by another year, the alien grows by 2 years. When you grow another year, the alien grows by 3 years. When you grow another year, the alien goes by 5 years. It's a line. Okay, so that's how you understand derivatives. I just want to emphasize this point again. Derivative is all about uh, we know the relationship between two things. We just plot them, we can visualize them and all that. But the question that always comes up again and again is when this when one of the thing changes, like your age changes. I hate to use the word variable because I don't want to confuse you. When your age changes, how does the related alien or your dad's age change? That's when you take the ratio, that's a derivative. Okay, and some people like to use the example of tangent, which means exactly the same thing, which is going back to our parabola, your age, alien's age. So when there's a small change in your age, right? This is the small change. There's a corresponding change in the alien's age. This ratio also happens to be at the tangent at this point. Okay. So again, a geek word. They call it a tangent. A tangent is basically at that point for a very small change in your age and for a very small change in the alien's age. When you take the ratio, that ratio will be exactly equal to the slope of this tangent. Okay. Now here is a trick. I'll leave you with this, and probably very useful. Okay, so let's say you have a function, right, or a relationship between two things, and now we'll probably use some advanced math. Again, feel free to just skip this part. You it's I would probably just remember the essence of the thing, but not these equations and things like that. So let's say you have a function, a relationship, right? Not all relationships are linear, they're good looking, things like that. It could be erratic as long as it's smooth. Okay. Now, let's say this is a function. This is a relationship between x and y. This is typically how it's taught in math. X is your age, y is someone else's age. In this case, I'll take a twist on it. Let's say x is my age, and y is my weight. Okay, and I found out the relationship. Okay, it's y is equal to 3x squared plus 2x plus 13. Some may not be true, but let's say it looks like that. Now the question is simple. When does my weight peak? Okay, what is my maximum weight and my minimum weight? This is all you need to remember. My weight, my maximum weight and my minimum weight will occur at the point where the derivative of that function is 0. Okay, which means that when dy divided by dx, which is basically the definition of derivative, change in y. They call it dy and dx because they're talking about a very small change in y divided by very small change in x, which is you can look at, you can think of this as z. Okay, some other thing. Okay, and z is equal to f dash of x. When z is equal to 0, that's when your weight peaks, or that's when your weight is minimum. How do we understand this, right? We know that at any point, the slope of the curve shows you the derivative of that curve, right? At that point. At this point, the slope of this curve gives me the derivative or the change, small change in y divided by small change in x. Now, at what point do we hit a maximum? The slope will slowly start decreasing, right? It will hit a 0 and then it will become negative. So, what's the simple explanation? When the slope is equal to 0, that's where you'll hit a maximum. Okay. There's a notion called local maxima, local minima, but don't worry about it. So when slope hits 0, and again, if this is the minimum, slope has to hit 0. So f dash of x is equal to 0 is the point at which the function will get its maximum value or the minimum value. This theorem is used again and again and again in, let's say you have a production functions. They're going to ask you when is the profit maximized. Okay, all you have to do is you have to write the profit in terms of cost or any other variable and take the derivative with respect to cost or number of units produced and set it to 0. That's when your profit is maximized. Simple. You can try it out and email me or shout out if you are finding out exactly what they tell you, which is, that profits are maximized when marginal cost is equal to marginal revenue, which is just a play on saying that the derivative is 0. Write out the equation, the full equation, where you have an equal to sign between cost on one side and profit on the other. Take a derivative and you'll see that marginal cost is equal to marginal revenue. Revenue is when the derivative is equal to 0. Nothing fancy.